Welcome to the second video of geometrical optics, otherwise also known as ray optics. So, in the previous video, we saw some properties of light, reflection at plane surface, then we saw spherical mirrors, then we saw image tracing, and at last we saw how sign convention works. In video 2 we will see we will try to establish the relation between u, v and f. After that we will see how f is half the length of radius of curvature. We will derive it practically, and at last we will look at how magnification in spherical surfaces and magnification and reflection in spherical surfaces work. So if you haven't seen the first video of geometrical optics, actually there were some concepts like paraxial rays that we will be talking about, that we will need in this video to establish this relation. So if you don't know what paraxial rays are, you should, although I will give a brief uh, very brief uh, explanation, but still you should visit the last video and see what paraxial rays are. Before diving into before establishing the relation between UV and F, one thing that I forgot to include in yesterday's video, and that is focal plane. Suppose this is a mirror, this is the pole, this is the center of curvature, and somewhere here is the focus. So this plane which is perpendicular to the principal axis and passes through the focus. Focal point is called the focal plane. Now let's establish the relation between UV and F. So as usual, we will take a mirror. This will be our principal axis. So this becomes our pole. Suppose somewhere here is the center of curvature, and somewhere here is our object. And suppose this object gives off a ray which touches the mirror surface somewhere here, and we call this point A. And as usual, by the laws of reflection, the ray will get reflected something like this, since it is a converging mirror. A second ray is given along the principal axis, something like this. And since any ray shot at the pole of a mirror is perpendicular to the surface of the mirror, so this ray will get diverged back and trace its original path. Now suppose from the center of curvature we take a line we take a line and join the center of curvature and point A. So this will be our radius of curvature. Now here will be our image. Now let's start naming the angles. Let's say this angle is alpha, this angle is beta, and this angle is gamma, and this angle is theta. Since this angle is theta, by the laws of reflection, and the radius of curvature is always normal to the surface of mirror. So by the laws of reflection, this angle also should be theta. Now remember that we talked about paraxial rays. Paraxial rays are those rays which are very close to the principal axis. And geometrical optics, we only talk about paraxial rays. So these rays AP, sorry, OA and OP are paraxial. Now, since we are dealing with paraxial rays, and we know that all these rays, all these rays are very close to the pole, we can say that the distance AP is almost a straight line, because see what happens, that if you take a curved surface and you zoom it and cut a very small part from it and zoom that part, you will see that virtually that part is almost straight. Okay. Another thing is that in trigonometry we have learned that for very small angles. Tan theta is equal to theta if theta is taken in radians. Let's come back. Let's remove all the unnecessary stuff. What we have here now is a triangles. So let's see in triangle AAC. Sorry, OAP. Tan alpha is equal to tan alpha is equal to perpendicular by base, and here perpendicular is AP, so AP by base is OP, which is almost equal to alpha because alpha is a very small angle. Similarly, in triangle CAP, tan no for beta we will have something else because we will not approximate beta. We can approximate beta just like we have approximated alpha, but for beta there is a different method that I want you to understand and know. So let's leave beta. In triangle IAP, tan gamma equals to AP upon IP, which is almost equal to gamma itself. Now why did not I approximate beta? Because you see CA and CP are radii of the sphere from which mirror is made. Okay, so in triangle ACP, CA is equals to CP, so it will be an isosceles triangle. Okay, so triangle ACP is an isosceles triangle. Now in a circle, arc is equal to radius multiplied by theta taken in radians. So we have the arc AP. This implies AP equals to R. We have R CP CP into beta. So we can say beta is equal to AP upon CP. That's why we did not approximate beta, because beta we can exactly calculate. Now let's see that let's start establishing a relation between the angles. So in triangles we have learned that if you have a triangle and you have an external angle, that external angle is the sum of these two internal angles. Okay, so in triangle OAC, we have beta equals to alpha plus theta, and in triangle CAI we have gamma is equals to, no, really sorry, in triangle OAI we have gamma is equals to alpha plus 2 theta. Now we need to eliminate theta. So what we do, we multiply, this is equation 1, this is equation 2, we multiply equation 2 1 by 2 and subtract equation 2 from it. So we will have 2 beta equals to 2 alpha plus 2 theta, okay, minus gamma equals to alpha plus 2 theta. This will give us 2 beta minus gamma equals to alpha. So we have eliminated theta. This will give us 2 beta is equal to alpha plus gamma. And let's see what we have. For beta we have AP by CP. So 2AP by CP equals to, for alpha we have AP by OP equals to, for gamma we have AP by IP. AP will get cancelled out and we will get 2 by CP equals to 1 upon OP equals to 1 upon IP. And this is where we get our relation between U, V and F from. Okay, so now let's see what is CP. CP is the radius of curvature, or the distance between pole and the center of curvature, which is also known as the radius of curvature. What is OP? OP is the distance of object from pole, and IP is the distance of image from pole. We put that here, 2 by R equals to 1 by U plus 1 by V, and this is where we get our relation between U, V and R from. So this was the relation between U, V and R. Now this same R later on. uh, Most of you must know that f is equals to r by 2. Okay, so 2 by r will become 1 by f, so it will become 1 by f equals to 1 by u plus 1 by v. This is what we all are usually. This is what we all are usually used to see. So why did not we write it like that? Because until now we still haven't uh, established the relation between R and F, which we will do now. But first, let's see. From the sign convention, we all know that here R, U, and V all are negative. So our relation will become something like 2 by minus R equals to 1 by minus U plus 1 by minus V. But in this particular case, all the minuses will get cancelled out. So some of you may ask, uh, is it universal? Will it work in every case? Yes, because uh, we have kept in mind the sign convention, and we have derived this result according to sign convention. So it will be applicable in case of any type of mirror or any type of situations. Now let's see the relation between R and F. What is F? F is the distance between O, P and F. P is the pole. F is the focal point. Okay. Now suppose we have a mirror and a ray is coming from infinity. So we know that any ray coming from an infinite distance becomes almost parallel to the principal axis. Okay, it gets reflected and intersects the principal axis at some point. Similarly, let's take another ray which is also parallel. It will also get reflected and intersect the principal axis at the same point. I'm fed up by this. Okay, why God, why? Okay, leave it. So we know that this is our focus point and this is our center of curvature and this is pole. So PF equals to F and PC equals to R. Now see the relation that we have derived earlier. that is 1 by sorry 2 by r equals to 1 by u plus 1 by f. Now in this case f nahi v. Now in this case what happens that u is at infinity. Okay, so 2 by r equals to 1 by infinity plus v is at the focal point 1 by f. So 1 by infinity is 0. We get 2 by r equals to 1 by f. And from here we arrive at the conclusion f is equals to r by 2. That's why I wasn't writing f earlier, because we were yet to derive the relation between f and r. So I guess for this video I will leave it until here only, and in the next video we will look at magnification, and after magnification comes refraction. Until then, stay tuned, and if you learned something today, congratulations to you. Please like, comment and subscribe.